Hello, I welcome you all in this presentation related with the subject materials processing, fundamentals and practical. We are talking about the metal forming processes. In the previous presentation, we have talked about the rolling, and in this one, I will be talking about the another bulk metal forming based process, forging. Forging is one of the very commonly used manufacturing process for making the products which are of high strength to weight ratio by ensuring that, and this is realized through the controlled flow of grains, controlled mechanical working in the cold forging, in case of cold forging, and largely defect free, means even if there are internal defects in the stock material, those are also closed and the corrected in the forged components. So, usually the products which are obtained after forging are really good in terms of the performance, and that is why it is very commonly used for making the products where high strength to weight ratio is crucial, like in connecting rods, crankshafts, the wrenches, even the wheel of the rails are manufactured through the forging. So, as far as the content is concerned, initially we will be talking about the approach of forging process, then types of the forging, and then open or closed forging, mechanics of forging, metal and the forging, how the metal type affects the forging, and the common defects observed in the forged components, typical advantages and the application of the forging. Okay. So, forging, we know that is a bulk metal forming based process which results in a very good high strength to weight ratio products. Why? Because it helps in improving the strength of the metal which has been produced in form of particular product. It results in very good toughness, and these two in turn results in the reliable products, because the product produced by forging is free from defects, coupled with the improved mechanical properties, and at the same time the process is very efficient. It is fast even for making the complex shape products. And another good part related to the forging is the minimum waste. There is no wastage in form of, like, say, chips which are produced in typical machining or in other manufacturing processes. But here the wastage associated, a wastage of material associated with the forging is very negligible. Okay. So, these are the few very important benefits as far as the material processing using forging is concerned. It results in very good mechanical properties, which in turn results the reliable products, efficient production even of the complex shapes, and the minimum wastage of the material. Okay. As far as the property advantage is concerned, we get very good strength and durable forged components. Why? Because the structure is refined, which in turn helps in improving the strength and durability of the product as compared to those which are manufactured by the casting, machining or the welding routes. The toughness of the forged products is also good, and that in turn results in a very good resistance to the impact, and the wear resistance is also good. The fatigue resistance is also enhanced. So, the forged parts offers the very better fatigue resistance under the fluctuating load conditions, and that in turn helps in improving the reliability and life of the product. And the controlled flow of the grains means the material grain flow, the flow of the grain orientation in the forged components can be controlled by proper application of the forces, that in turn allows the controlling the strength as per the need of the application. Okay. And that is why we get a much more enhanced strength in certain directions. So, the directional strength is achieved through the forging by controlling the flow of metal and orientation of grain in certain specific directions as per the need of application. As far as the production advantages of the forging is concerned, very efficient use of the material means there is no wastage of the material, and complex shapes can be produced. So, the shape complexity is concerned, very simple to moderate to complex shape geometry products can be produced very rapidly, but this kind of the production will be justified by the forging in case of the medium to high volume production only. If very few units are to be produced, then the designing, fabricating the relevant die will be a costly affair. So, what we prefer, if the products need to be manufactured in large volume, then forging is moderate to large volume, then the forging is preferred. The process is fast, it can produce the products and parts very quickly, especially for medium to the large volume production. And it reduces the machining because the forged parts are close to the desired size and shape which is to be made by the forging. So, the post processing required in case of the forged components is limited as compared to that is needed in case of casting, welding or machining. So, this in turn reduces the production time and the related cost. The what kind of the metal which can be forged? Material must have good forgeability, which means the materials preferably should have lower yield strength and the coupled with the good ductility under the forging conditions. So, those metals which are showing reasonably good ductility and the lower strength, moderate lower strength even under the ambient condition can be cold forged. Otherwise, metal must be heated to the higher temperature for forging purpose. Say aluminum and copper can be forged at room temperature, but they are easier to forge at a higher temperature because of the reduced yield strength and increased ductility. So, the common metals like the various steels, aluminum and titanium are the metals which are used for manufacturing, making the products by the forging route, because these offer reasonably good forgeability. So, what is the approach of forging? If you want to see the approach of forging, in forging what we do basically, the bulk metal deformation is realized, and how it is realized, like say this is the bulk material. So, we will be applying the compressive force, this is very normal thing. So, in forging basically we use the compressive load is applied on the material which is to be deformed. So, using the compressive load, material is deformed, deformation is realized plastically, or plastic deformation is realized. Okay. Now, depending upon the condition, if it is above the recrystallization temperature, we will be terming it as a hot forging, and if it is under the ambient condition, then we will be saying it as a cold forging. Okay. Since at high temperature material show lower yield strength and greater ductility, so it will require lesser compressive load to cause the plastic deformation. Now, how it can be done? So, how depending upon the way by which material is subjected to the plastic deformation, that leads to the two variants. One is called open forging and another is closed forging. So, in case of the open forging, we use the hammer or press with the flat surface to deform the material. So, when the load is applied, the flat surface will be pushing the material in downward direction and deforming it plastically. Okay. So, depending upon the way changes are taking place, again we have the two types of the approaches which are called upsetting or drying out. Okay. So, the way by which the material is experiencing change due to the plastic deformation, that leads to the further categorization like upsetting or the drying out. Okay. I will be talking about that little in detail later. So, what is open and closed forging? In open forging, we use the flat surface of the either hammer or of the press to apply the compressive load on the material, so that it gets plastically deformed. But in closed forging, what we do, we try to create a die, okay, like this, of the desired geometry, okay, like this. Say, so this is upper die and this is lower die, okay, and the raw material is placed between these two dies, okay, and then compressive load is applied from the upper die, so that the material between the two dies in this closed cavity flows laterally, upward, downward and laterally. So, the metal can flow in different directions. So, this kind of the flow of the metal, when the dies are closed, a closed cavity is formed, we term it as a closed die. Okay. So, when a dies, a combination of the dies forming a closed cavity in which metal will be subjected to the plastic deformation, will be terming that as a closed die. And when a flat surface of hammer or a press is used to cause the plastic deformation, will be terming that as a open forging. So, maybe in one go, when the load is applied from the upper die and material is between the two dies is subjected to the plastic deformation, and then after completing the flow of the metal between the two die, metal will be taking the shape according to the cavity. Okay. So, this is how it is done. So, this is how it is done in case of the closed die, and in open die, since the metal will be flowing laterally only, there is no control over the flow of the metal in other directions, it will be flowing laterally only. So, we need to manipulate the material between the blows or between the steps when the load will be applied through the hammers, whether it is manually operated or power operated. So, between the blows of a hammer having the flat surface, the raw material or stock material is manipulated in between, so that the desired shape can be realized. But this kind of manipulation will require a lot of skill to get the desired size and shape. So, now this is one part. Now, we will see the other aspects, what is upsetting and the drying out. In case of upsetting, say we take the material having the height say h and the diameter d. Okay. When the load is applied, so what will happen due to the application of the load? There will increase in diameter and a reduction in length. Okay. So, the diameter will become capital D, and this say this h, there will be change in the height. So, height will change say to this capital H. So, the height will be reduced and the diameter will be increased. So, when such kind of the change due to the plastic deformation under the upsetting conditions due to the compressive load being applied on the material, when there is a increase in cross sectional area in form of increase in diameter coupled with the reduction in height or thickness, when this happen, we call it as a upset forging. Okay. And when we have the another one, in case of the drying out, just opposite happens, like this is the flat surface of the hammer or the die, or this is the material. Okay. So, this is having say particular the diameter and the height. Okay. So, when we apply the compressive load, there is a lateral flow of the material, there will be reduction in the thickness and increase in length. Okay, when the lateral flow takes place. Okay. So, in this case, when there is a reduction in thickness and increase in length of the material due to the lateral flow, it is called drying out. These are the two broad classifications based on the approach which is being used for the forging purpose. So, that is what is there in upset and the drying out approaches. So, plastic deformation of metal during the forging process can occur broadly in the two ways. One is upsetting and the second is the drying out. Okay. So, in upsetting we can see this is the stock material and this is the flat surface of hammer. When the load is applied in downward direction, the material flows laterally. Okay. It flows literally, and that in turn increases the diameter, reduces the height. This is what happens in case of upsetting, and just opposite will be happening in drying out. So, in upsetting, what we do, the load is applied along the axis of the workpiece, but in case of the drying out, this is the axis of workpiece. So, the load will be applied perpendicular to the axis of the workpiece, and in that case significant thinning will be happening coupled with the increase in length. Okay. So, upsetting increases the cross sectional area, reduces the height of the stock if when the force is applied along the axis, and in case of the drying out, compressive force is applied in direction perpendicular to the axis of the metal, which increases the length and reduces the cross sectional area of the material. So, these are the two broad ways by which the change in shape of the stock material during the forging will be happening. Okay. The force for applying the compressive force for causing the plastic deformation during the forging can be applied either with the help of hammer or with the help of press. Hammer can be operated manually or it can be powered, okay, where electric arrangement is used, electric motor is used to operate the hammer. In case of the hammer, it will be applying the impact load on the surface of the stock material to cause the plastic deformation. Usually this results in the open forging. Okay. While in case of the press, the load is increased gradually, like say there is a top surface, on the top surface of the stock material, load magnitude is increased gradually to cause the plastic deformation of the material as per the shape desired, okay, with the help of the die cavities. So, in case of the hammer, blows are applied. So, compressive force for upsetting or drying out can be applied manually or using mechanized system like the hammers or presses. Hammer applies the blows in form of the impact loads on the metal for drop forging, while press exerts the continuously increasing load for machining or press forging. So, here if we see, this is a broad classification based on the kind of the way by which compressive load is applied. Okay. For drop forging and for smith forging, hammers are used, in which the impact blows from the hammer is used to cause the plastic deformation, while machine or press forging uses the press for applying the compressive load. So, the difference is, in case of the hammer, blows are used or impact load is used, while in case of the press, continuously increasing load is used, so that material is squeezed in the space between the die to impart the desired shape of the die. Okay. And so, the many bulk metal forming processes like forging, coining, wire drying are based on the drying out operation, where the reduction in cross section and the increase in length will be taking place. Okay. As I have said, there are two types of the broadly dies. So, the plastic deformation of metal for forging is realized through the compressive load, but where this load is applied and how this load is being applied, that results in the difference here. So, the compressive force is applied for causing the plastic flow of the metal in lateral direction. Okay, the open or closed die. So, when the die is open, means the surface is flat like this. Okay. So, this is the stock material. In case of the open die, this is the top surface, this is the bottom surface, and in between we have the stock material. Both top and bottom surfaces have the flat surfaces. Both open and the top and bottom dies have the flat surfaces, and in between those surfaces the stock material is placed and then load is applied. So, when we have the flat surface, in case of the open dies, material freely flows laterally without restriction to flow in particular direction, but it flows freely in lateral direction. Okay. So, in case of the open die, metal flows literally without restriction between the blows of hammer, or in case of the press, when the load is continuously increased. In case of the closed die, we have, like say, this is the upper die and lower die. So, the load will be applied. So, initially the die will be closing. Okay, and the material will not be deforming much in the beginning. Once the die is closed, then material will be flowing in the different directions. Okay, to fill the cavity which is being created by the dies in closed condition. So, in closed die, metal flows and fills the closed die space to produce the size and shape. So, this die space, once it is closed like this, then it will be creating a closed space, and then application of the compressive load will be causing the flow of the metal in different directions. It is very important that the material flows. If the flowability of the metal is very limited, then it will not be flowing and filling those fine zones and cavities which are present in the die cavity space, and that will be causing the defect or unfilled sections in the die. So, we will be getting the product of some other shape than one which is desired. So, in case of the closed die, metal flows in different directions and fills the die cavity to produce the desired shape. So, in metal can flow in different directions during the closed die. But here, in case of the closed die, the volume of the material must be optimized in such a way that it is good enough to fill the die cavity, and a part of the material is left and squeezed out as a flash at the circumference of the wherever the die at the parting line where the both the dies are meeting. Okay. But in case of the forging, the volume of the material largely remains constant, because hardly there is any loss of the material, except that if there is a stock material, if it is subjected to the, like say, formation of some kind of the oxides, or continuous blows are causing little chipping of the material from the surface, then the loss of the material from the stock during the forging is very limited. Okay. So, whatever the loss that will be happening during the forging, that will be primarily occurring due to the oxidation or chipping of the metal, especially under the forging conditions when the hammers are used, when there will be significant possibility of chipping of the material, especially under the low temperature conditions. Okay. So, now we will talk little bit about the open die forging. In open die forging has a flat surface, about which I have already said, allowing the free lateral movement due to the application of the compressive load. Okay. Therefore, material being forged is manipulated, must be manipulated to between the impact from the hammer to get the desired size and shape, and this requires lot of skills. Actually, manipulation of the material between the flat surfaces in the open die needs skills to get the desired size and shape. So, here we can see how the shape will gradually be attained sequentially when the open forging is used. Say the material is of the smaller diameter and greater height. So, initially, so this will be causing the upsetting coupled with the reduction in height and increase in diameter, and this will be happening in sequence. The point here is we do not get the final size and shape in one go. It may require a number of the stages to achieve the final size and shape. Okay. So, these are the different stages through which material may pass for attaining the final size and shape of the product which is desired. So, in case of the open die forging, we may continue to manipulate the material between the blows until the desired size and shape is realized. In case of the closed forging, what is important, like there is a upper die and lower die, which can be termed as the die and punch, and this is the stock material placed in between the dies. So, when the die is closed, the material will be flowing in the different directions and it will be filling the die cavity. So, this is the first stage when a material has been partially processed and a particular shape has been achieved. Then it will be further processed in another die, which will be taking the material further closer to the shape desired. So, this is the another die with the another shape. So, this material is placed in another die and then again forging is done, and it will be giving us the shape which is further desired, which will be closer to the desired one. So, this is the second stage when there will be further change in shape, and this shape will be closer to the one which is desired, and when this shape is further subjected to change using another set of the die, this is say third set of the die. So, here the intermediate or the partially processed material, when used for further processing during the forging, this again will be subjected to the forging and it will be experiencing lot of change in the shape and resulting in the final product in form of this product. So, the point here is the final product is may require a number of stages of gradual change in shape through the different set of the dies. It may require number of the dies and die sets, and in each die set will be modifying the material in such a way that it is reaching closer towards the final product shape. Okay. The closed forging die is just like a mold cavity used in castings, forming a cavity corresponding to the shape or geometry desired in the product, and raw material is placed between the upper and lower half of the die, and then compressive force is applied to facilitate the plastic deformation. Okay. Then the compressive load can be applied either in form of impact or blows in case of the drop forging, or it can be continuously increasing load, or it can be applied in form of pressure or the machine forging. Okay. Similar to the rolling, since the rolling also required number of stages to attain the reduction in thickness which is desired. Likewise, forging may also take many sequential steps gradually converging towards the size and shape which is desired in the product, and this is done using the gradually changing die shapes to get the final product. So, the dies are designed in such a way that they will help in producing the product of the changing shapes gradually towards the final shape which is desired. Okay. Metal property, flow and soundness. It is very important that material shows the good forgeability in terms of the ductility and flow stress under the forging conditions. So, like any deformation based process, material should have enough ductility and preferably low flow stress. So, the efforts required to cause the forging are minimized. Okay. Although we know that when the metal is heated to the higher temperature, because of the recovery and recrystallization, metal gets softened, ductility is enhanced, and their flow stresses are reduced, the work hardening tendency is eliminated. So, that in turn facilitates the forging. That is why hot forging are relatively easier as compared to the cold ones. Okay. And the flow of the metal during the forging can be complex, because in closed die it will be flowing in multiple directions, lateral, bending, and in different directions. So, it can be complex. So, if the material does not have enough flowability, then it is possible that it may not fill the cavity completely, and that in turn will be leading to the defect. Okay. So, such deformation means the material is flowing in the different directions, and if it is not proper, then it will be leading to the number of defects in form of cracks, in form of a lot of defects are left on the surface. About that I will be talking in the coming slides. Okay. And one good thing also happens, that if the material is having the defects like cracks and the porosity, then these are closed due to the significant plastic deformation that will be happening under the forging conditions, and that in turn will be increasing the soundness of forged products. Okay. We have said that depending upon the way by which compressive load is applied, the drop forging type or press forging type. In drop forging, impact or the blows of the hammer are applied on the stock material to change the shape as per the need, while continuously increasing compressive load is applied in case of the press forging. But this in turn results in the lot of difference in the properties of the product which is being made. Continuous impacts on the surface by the hammer causes the increased possibility of this more surface layer deformation as compared to the one at the core. So, excessive or severe plastic deformation, grain refinement, work hardening can be observed in case of the impact forging if it is under the cold condition. Okay. While core may remain not much affected by this, but when the press forging is applied, the deformation is more uniform across the section or across the thickness of the material, and that will be causing the more uniformity in terms of the changes which will be experienced by the material during the press forging. Okay. So, the heterogeneity or anisotropy that is experienced in the drop forged product, that will be much more as compared to the one which are press forged products. Okay. In case of drop forging, near surface layers are subjected to the severe plastic deformation, grain refinement, and work hardening, especially under the cold conditions, and that in turn causes significant hardening of the surface, more surface hardening as compared to the layers. That is what we can see here. Say this is the component made by the drop forging. So, surface layers will be experiencing greater strain as compared to the core, and if we measure the hardness variation from the surface to the core, then we will see that surface hardness is greater as compared to the one at the core. So, this kind of the surface hardening is attributed to the severe plastic deformation, grain refinement, and work hardening if it is taking place under the cold conditions. This kind of the when the drop forging is carried out, this kind of the variation will be somewhat less when the hot forging is performed. Okay. In case of the press forging, continuously increasing load is applied during the press and machine forging, which in turn causes the squeezing action, resulting in more uniform flow of the metal through the thickness, reducing the severity of anisotropy, which is observed more in case of the drop forging. So, more uniformity in properties are observed in case of the drop forging as compared to the press forging. So, as I have said, press forging, continuously increasing continuous squeezing of the metal between the closed die during the machine or press forging needs very high capacity. You see, press forging needs a very high capacity press. Okay. So, to apply the high stresses and facilitate the flow of the material, okay, during the press forging. So, because of this high requirement of high capacity presses which is needed in case of the press forging, the size of component that can be made by the press forging is limited. Okay, because for making the large size component using the press forging, it will require very high capacity presses, and which may not be available. Okay, therefore, size of the press or machine forged component is limited by the capacity of press, and therefore, the machine and press forging is particularly preferred for making the small size components, because we need very high capacity presses for forging. In case of the press forging versus the draw forging, you see the continuous blows and impacts during the smith or draw forging makes the surface more rough and increase the tendency because of the excessive surface layer hardening, okay, especially under the cold conditions. And in case of the machine and press forging, this allows the controlled flow over the grains and their orientations, and that allows the directional strength, means we can make the component with the desired direction of the grain orientation, say in case of the shafts, axles, gear blanks, spindles, hooks, which will help in maximizing the strength in a specific direction and enhance the capacity and the reliability of the component which is being made. As far as the comparison is concerned of the different types of the forging process like smith forging, draw forging, press forging and machine forging, compressive load in case of the smith forging and draw forging is applied in form of the impacts. In case of the press forging, it is squeezing or continuously increasing load. For squeezing action, it is applied, compressive load is applied with increasing magnitude of the load through the squeezing action, and for machining forging also same thing is done, continuously increasing load to realize the squeezing action. The type of the die for smith and draw forging: for smith forging it is open, for draw forging, press forging and for machine forging it can be closed. And for surface roughness that is produced through the smith forging and draw forging is rough and jarred, and it is smoother in case of the press and machine forging. Anisotropy is significant both in case of the smith and draw forging, and it is lesser in case of the press and the machine forging. There is no flash formation in case of the smith forging, but in draw forging, press forging and machine forging flash is produced. Metal and the forging: metal significantly affect the forging thing because the flow stress and the ductility, these are the two heavily dependent on the type of metal and the forging conditions, okay. So it is very important that the metal is considered when identifying the suitable forging conditions. The type of metal significantly affects the forging conditions, including the temperature of the metal, okay. For aluminum, we may not require very high temperature as compared to the steel, then further higher temperature is needed for the titanium. Okay. Accordingly, the flow stress, if the material is of the low yield strength, lower flow stresses, then it will require lesser force and lesser compressive load as compared to those which are offering the higher yield strength and greater resistance to the thermal softening. And the potential for the defect also depends on the type of the material which is to be forged, because of the increased sensitivity to the environmental gases, increased sensitivity towards the temperature control. Like in titanium, forging of the titanium is very difficult because it requires a suitable atmospheric control in which it will be experienced, and very close control over the temperature that is needed when titanium forging is realized. Different metals exhibit varying the forging characteristics, and therefore optimal forging parameters also are found to be different. Say temperature, few metals will be more suitable for like say hot forging, and others may also be okay for cold forging, okay. Pressure is needed as per the flow stress of the metal and the temperature under which the forging is to be done, because increasing the temperature will simply help in reducing the flow stresses. And defect formation tendency heavily depends on the kind of the metal which is being processed or subjected to the forging. Hot forging temperature is usually above the recrystallization temperature, okay. And when it is done, heating helps in reducing the yield strength and enhancing the ductility. So that is one part, and therefore a hot forging, when we heat the metal above the recrystallization temperature, allows easier deformation and shaping because it requires lesser force, and the metal, the flowability is enhanced and that flows very easily and effectively. So hot forging suits for steels, aluminum, copper and titanium alloys. However, the temperature will depend on the specific metal and the kind of the ductility that is needed, depending upon the complexity of the shape of the cavity or the die or the product which is to be made. Okay, warm forging involves heating of the metal below the recrystallization temperature, but certain percentage of the recrystallization temperature, and it suits for the softer metals like aluminum and the magnesium. For the cold forging, you see, material should have very high ductility. This is one requirement, and reasonably low yield strength that is preferred. But when the cold forging is done, we get the benefit of work hardening, increased hardness, increased strength. So, cold forging involves the shaping of the metal at room temperature, but it requires very high pressure to cause the plastic deformation. But due to the work hardening, we get the increased strength and the hardness due to the work hardening effect, and it suits for steel, aluminum, and other certain steel, copper, and other alloys. Okay. Pressure for forging varies depending upon the metal as per the flow stress and the shape desired. More complex is the shape, greater will be the pressure that will be required to ensure that material flows and fills the fine cavities which are there in a metal. Apart from that, certainly the type of the metal will significantly affect the pressure and at a given temperature or for a given forging conditions. So, higher metals like steel and other alloys often require higher pressures due to the higher strength and lower ductility, especially at low temperature. If we increase the temperature of forging, then these requirements will be reduced. The pressure requirement will be reduced and flowability will be enhanced. So, metals like aluminum, copper can be forged with relatively lower pressures, especially when they are hot. Okay. So, now what are the specific metals and the forging conditions which are used? Steel commonly forged at a higher temperature. Aluminum is a lightweight material that is relatively easy to forge, especially at a higher temperature. Copper is also a ductile metal that can be forged easily at a high temperature, and titanium needs a lot of precautions, as I said, controlled environment to avoid the interaction with the environmental gases like oxygen, nitrogen and hydrogen, and close control over the temperature to ensure that beta transition temperature is kept in mind. So, very close control over the temperature is maintained. What happens if the temperature is too high? It will compromise with the properties of the product that will be made due to the grain coarsening, and if temperature is low, then it will increase the cracking tendency due to the limited flowability. Okay. Now, as far as the mechanics of the forging is concerned, the true strain, you see, will be causing the plastic deformation. So, obviously metal will be strained. Okay. So, depending upon the way by which change in the shape of the material which is taking place, we try to calculate the true strain or the strain being experienced by the material. True strain is calculated from the change in height or thickness of the stock due to the compressive load being applied. So, the log of the final height divided by the initial height, this is used to determine the true strain at a particular instant or in one step of the forging. Then the compressive load for upsetting is obtained from the sigma AV, that the average flow stress, and the area which is in contact, area of the stock material which is in contact through which the load is being applied to cause the plastic deformation. So, the forging force A is the area through which the load is applied on the stock to cause the plastic deformation, and the average flow stress, it will be absent. The strain hardening will be absent in case of the hot forging. When we are dealing with the little complex shapes, in that case shape factor is considered for determining the forging force, and what we do in that case, shape factor CF is obtained. So, CF is obtained from the equation like mu L by H. So, L is the contact length and H is the height of the stock at an instant, and the length of the contact with the die surface is the L, and mu is the friction coefficient. So, this equation is used to determine the shape factor, and when the shape factor is considered, then forging force is obtained using this relation CF multiplied by the average flow stress into the area which is in contact, area of the surface of the stock material which is in contact when the forging is done. As far as the forging defect is concerned, the common issues observed in the forged components due to the faulty procedures is like unfilled section, cold shut, scales and pits, die shifts and flakes. Flake happens particularly due to the chipping, die shift happens due to the misalignment upper and lower die, then it will be changing the shape of the product which is being made. Scaling happens due to the oxidation of the metal due to the exposure under the high temperature conditions. Cold shut happens due to the limited flowability, low flowability of the metal, leading to the crack like defect at the corners where the flowability of the metal is very limited, and unfilled section when the stock material being used to fill a given cavity is limited. So, the few unfilled section will be left, or the metal is having very limited flowability. So, it is not able to flow and fill each fine sections of the die cavity. So, that is about the broad reasons behind each kind of the defect. Unfilled section in forged component occurs due to the insufficient charge material, stock material in the die cavity, and apart from that, limited flowability of the metal during the forging conditions of the complex shape. So these two will be leading to the unfilled sections. Like say the die cavity is like this. Okay, so if the flowability of the metal is very limited, then it will not be filling this section. Metal can flow and fill different other zones which are simpler, but it will not be filling the complex shape cavities within the die. Okay, and that will be leading to the formation of the unfilled section. Cold shut is a kind of the fine crack which is observed at the sharp corners of the forged components, especially when the radius at the corner is very fine and the material is not able to flow properly under the forging conditions. Pits and the scales are the defects which will be formed primarily due to the oxidation of the surfaces and impurities under the forging conditions. Die shift happens due to the misalignment of the upper and lower die. So, we will be getting something else than what is desired, and the flakes are formed especially when the material starts getting embrittled at the surface due to the continuous impact and blows of the material at the surface. So, the flakes are formed due to the continuous impact of the upper surface of the die on the stock material, and this particularly happens when the material loses its ductility or its flowability is limited. So, presence of flakes on the surface of the forged component can result in the rough and jarred surface. So, how to avoid the forging defects? We can avoid the forging defects by reducing the, by cleaning the surface, cleaning the stock material. So, this will be leading to the scale and pits kind of the defect can be reduced by this. Further, if the oxidation is avoided in the forging conditions, proper control over the forging temperature is realized, because if the material doesn't have the enough the ductility, or if it has a higher yield strength, then it will have limited flowability, and that it will in turn will be leading to the defects like unfilled section or the cracking. So, there will be issues if the proper forging conditions are not, forging temperature is not maintained. The die should be well designed, means it should not have very sharp corners where flow of the metal will be limited, otherwise it will be leading to the defect like cold shut. And the right volume of the material must be used, otherwise it will certainly be leading to the formation of the unfilled section. And machine must be robust enough to avoid the possibility of misalignment, otherwise it will be leading to the misalignment kind of the defect, and we will be getting the forged defect in kind of the in form of the shape which is not desired. As far as the application of the forging is concerned, it is particularly used for making the high stress components, products which are to be used under the high stress conditions. For critical applications, because these are of high strength, high toughness, high wear resistance and high strength to weight ratio. So, the forged parts are used especially when the demand for high strength reliability is very high, high strength to weight ratio is desired. So, in automotive, aerospace, hooks, tools, these are the kind of components and the sectors where the forged components are preferred. Crankshaft connecting rod are very common example of the forged components. Okay, so connecting rod, crankshafts, wrenches are frequently manufactured via forging due to their high strength to weight ratio requirement. Now, I will summarize this presentation. In this presentation, basically I have talked about the approach of the forging and the different types of the dies, the way by which the pressure is applied for the forging, what are the conditions which are needed for forging, what are the common types of the defects, and what should be done to avoid the forging defects in the components, so that the sound and product with the desired size and shape can be produced. Thank you for your attention.